Ever tried getting directions from a virtual assistant and felt like you were talking to a brick wall?
Oh, all the time. It's kind of wild how often those AI things just totally miss the mark.
Right. It's like, come on, I need directions, not a weather report. But guess what? A team at Google Research might have cracked the code with this thing they call the transformer.
And we're diving deep into their paper, Attention is All You Need, to, figure out how it works.
This paper's a pretty big deal, right?
Huge. It basically flipped the script on how AI gets human language. Like, it's the basis for all this crazy progress we're seeing.
Okay, so before we get into all the nuts and bolts of this transformer, let's set the scene, yeah? Imagine reading a whole book, but like forced to go one word at a time.
Ugh, sounds painful.
Totally. And that, sadly, is how a lot of AI models were dealing with language before the transformer came along. They were all about these things called recurrent neural networks, RNNs for short.
Yeah, RNNs were okay at following stuff in order, like one word after the other, just like you said. But man, were they slow. And remembering things from way back in the text, forget about it, especially with long sentences or whole paragraphs.
Like trying to remember the start of a sentence by the time you hit the end is just gone.
Exactly. Then there were convolutional models, which were kind of like peeking at the text through a tiny little window. They were better at getting what was going on nearby, like the meaning of a few words together, but the big picture, not so much.
Like trying to figure out a whole movie from just a couple of frames, you miss all the good stuff.
Perfect way to put it. These older models, even though they were huge back in the day, they had their limits. Too slow, too focused on tiny bits, or sometimes both. The field was like begging for a shakeup.
And then the transformer struts in with its secret weapon. Attention, huh?
It's honestly brilliant. Attention, like we're talking about here, means this model can zero in on the parts of the text that really matter for understanding the whole shebang. Like when you're chatting in a loud room, you got to block out everything else and focus on what that person's saying.
So it's not getting tripped up by every single word.
Yeah.
More like picking out the important stuff.
Mm-hmm.
Kind of how our brains do.
You got it. And this whole attention thing, it's not just about single words either. It can track how words connect to each other, even across a whole page. Yeah. There's this cool diagram, figure 3 in the paper, shows how the transformer can link a pronoun all the way back to its noun, even if they're sentences apart.
Whoa, it's like those aha moments in a mystery novel where a clue from the beginning suddenly makes sense.
Exactly. That's the beauty of it. It sees those connections that used to trip up older models. And get this, it doesn't have to go step by step. It can look at the entire text all at once.
All up all at once, like speed reading, not word by word.
You got it. This parallel processing thing is huge, makes training these models way faster. Think weeks or months slashed down to, in some cases, just a couple of days.
No way. No more waiting forever for the model to, like, learn its stuff.
Yeah.
But so this global understanding thing, what's that look like in real life?
Okay, well, think about a word like bank. Could be the place you keep your cash, could be the edge of a river,
Yeah.
right?
Totally.
The transformer. With this ability to see the whole picture, it's way better at figuring out the right meaning based on what's around that word. It gets all those little nuances that other models, they just missed.
Like having a dictionary and a grammar guru all rolled into one. Okay, but how does this transformer thing actually work? Give me the behind the scenes, but like easy enough for us non-techies.
At its core, it uses this encoder-decoder setup. Picture translating, I don't know, a secret message?
Ooh, I'm picturing a decoder ring.
Well, the encoder's like the first step, right? It
Yeah.
checks out the original message, pulls out all the important stuff, the main ideas, how they connect. Then the decoder takes that info and uses it to make the translated message.
So encoder breaks it down, decoder builds it back up, all fancy in a new language, and all thanks to this attention thing, right?
Exactly. But it gets even cooler. Inside both the encoder and decoder, there's this thing called multi-head attention.
Multi-head. Sounds kind of intense, like a mythical beast.
Nothing that scary, I promise. Imagine watching a movie with friends.
Okay, I can get behind that.
Afterwards, you're all talking about it, right? Maybe you're digging into the plot with one friend, talking characters with another, and someone else is all about the special effects. Each of you is focusing on a different part of the movie, yeah.
So different heads are like looking for different things in the text at the same time.
Bingo. One might be all about the grammar, another's checking out the emotional vibe, another's getting the overall meaning. This lets the transformer understand the text way more deeply than those models stuck with just one way of looking at things.
Okay, this is starting to click. But something's still bugging me. If it's looking at everything at once, how does it know the order of the words in a sentence. I mean, word order is important, right?
You're totally right. You can't just scramble words up. Those old RNNs, they went one by one, so they just got word order automatically.
Yeah.
The transformer, with its whole doing everything at once thing, needed a different approach.
Which is where positional encoding comes in.
Ding, ding, ding. It's basically like giving each word a little ID tag that says where it belongs in the sentence.
So it's like assigning numbers to players on a team so you know who's playing what position, even if they're all running around like crazy.
Exactly. Positional encoding lets the transformer keep track of the order without messing up its super fast processing. It's elegant, really.
Okay, so you've explained how it works, but does it actually, live up to the hype?
Oh, absolutely. In fact, the transformer kind of blew everyone out of the water, especially for machine translation, which is a really tough nut to crack for AI.
Okay, but how much better are we talking? Like a small step up or a whole new ball game?
Whole new ball game. For English to German, it beat out all the top models, even the ones that combined, like a bunch of different techniques. And get this, for English to French, they got state-of-the-art accuracy in just 3.5 days of training on 8 GPUs.
3.5 days, that's crazy fast. Some of these models take weeks, months even, to train, right?
That's the beauty of parallel processing. The transformer can handle tons of data super efficiently. But faster and more accurate translations, that's not even the whole story. It's about what this means for how we use AI every day.
Right, so for those of us who aren't, like, translating novels, what's the big takeaway?
Well, think about how we already use AI that deals with language, our virtual assistants, those chatbots that pop up everywhere, even just predictive text. The transformer set the stage for all that to get way smarter, way more helpful.
So chatbots that actually get what we're asking, translation apps that sound like a real person, maybe even AI that can help us write emails or, like, whole reports.
Exactly. And here's another cool thing the paper shows: the transformer can do way more than just translation. They even used it for this thing called English constituency parsing, which is basically figuring out how sentences are put together grammatically.
So it's not just swapping words around, it's actually learning how language itself works. That's wild.
It's groundbreaking, really. And because it's so adaptable, researchers have been tweaking it, adapting it for a crazy amount of language-based tasks, like the Swiss Army knife of natural language processing.
This attention is all you need. Paper definitely lives up to its name. So what's next? Did this paper, like, solve AI understanding language as well as humans?
That's the million-dollar question, but it was definitely a turning point. The transformer kicked off a ton of new research, leading to even more powerful and complex models, stuff we never thought possible before.
It's crazy to think one paper could have such a huge ripple effect. Makes you wonder what other breakthroughs are just around the corner.
Totally. It's an exciting time to be in AI and language. Who knows what we'll discover next?
This deep dive has given us a lot to think about. If you're listening, we want to hear your thoughts. What possibilities or even concerns come to mind when you think about AI that can get language like the transformer can? Find us on social media. Let's keep this going. Until next time, happy diving.